So today we are talking about exponent rules. You had these back in Algebra 1 and you use them occasionally. When you multiply exponents, the bases have to be the same, but the trick is to add. You're still multiplying, it's still a multiplication problem, but the trick is that you add the exponents. Then when you're dividing, let me write the division problem a different way. You subtract the exponents. If you have a power to a power, an exponent raised to another exponent, that's when you multiply. Okay? So you got to kind of see the difference. When I call them side by side, you add. When you have a power to a power, you multiply. This rule is saying that the exponent, if there's parentheses, the exponent kind of bosses around the A and the B. Here, it bosses around the A and the B. Anything to the 0 power is 1. We'll talk a little bit about negative exponents. And we'll learn this on 8-4. This is what we'll be learning on 8-4. Okay, so let's practice a little bit. Again, they're reiterating right here that if you have, if you're multiplying and your bases are the same, like the x's are the same, you add the exponents. If you're dividing, remember a fraction is a division problem. If you're dividing, you subtract, okay? So this would be x to the, you add up 3 to this 3 and 6, and you get x to the 9th. This would be x to the 15th. This would be x to the 8th. This would be x to the 1st, and you don't have to write that. And let me show you another way to help you divide. When you are dividing, you have to be careful that you write them all. That's x to the 9th and x to the 8th, 4, 5, 6, 7, 8. So if you get lost in what you're doing with division, you can always cancel out. So now I have x to the 1st, and it's on the top of the fraction. Okay, over here, this is multiplication again. 2 times 3 is 6. So you go ahead and multiply the big numbers because 2 times 3 is 6. You're multiplying. But you add the exponents. So you get, you get 6x to the 15th power. Here you subtract because it's division. You get x to the 7th. Now this section of the notes explains why anything to the 0 power is 1. That was on the first page of the notes. And that's just kind of something fun to know. What we just learned is you subtract. So 7 minus 7 is 0. But another thing we know is that anything divided by itself is also 1. So if x to the 7th divided by x to the 7th is 1, and x to the 7th divided by x to the 7th is 0, then these two guys must be equal also, those two. X to the 0 equals 1. So whenever you encounter an x to the 0, you kind of mark it out. It's really times 1, but you really don't even need to write the 1. You just kind of let it go into outer space because it's anything times 1 is not affected. It just is the same thing. So anything to the 0 power is 1. So here's your anything. Anything to the 0 power is 1. This next section is helping us with power to a power. When you have a power to a power, you multiply. Okay? So we have x to the 5th to the 3rd power. So you multiply that and you get x to the 15th. The reason is this. You have x to the 5th 3 times. X to the 5th and x to the 5th. It's like x to the 5th 3 times. And so if you count all those up, that's x to the 15th power. So this is x to the 6th. This is x to the 28th. We're multiplying. And it's kind of hard because you have to, it's not hard, but you have to just kind of watch your brain and stay on top of your brain that it doesn't do something silly like add. So this is x, whoops, this is x to the 12th. Now here, the 4 is bossing around the 2 and the x squared. So 2 times 2 times 2 times 2 is 16. And then you have a power to a power, so you multiply and you get 16 8 to the x. I said that wrong. 16x to the 8th. And same thing here. This 2 is bossing around the 3 and the x to the 3rd. So you get 9x to the, you're going to multiply 6th. All right. So then we have some more quotient properties. So this 2 bosses around everybody. We get x to the 6th because you multiply over x to the 4th. Now it's just a plain division problem. So now you subtract. So you get x squared. And once again, 3, 4, 5, 6. 1, 2, 3, 4. If you forget, write it out like that. I can't convince kids to do that, but so I don't know what the problem is. Okay, here we get 2 squared, and we get 5 squared, and we get x to the 12th because we multiply, and x to the 10th. So we have 4 on the top from your x squared, and 25 in the denominator because of your 5 squared. Then we have to subtract. So you get x squared. Be sure that you're putting them on the top or where you have the leftovers, where you have the biggest one or the biggest amount. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I lost count. Let me count again. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have 1 too many. So let me erase that real quick. Okay. So now, you cancel, 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 cancel. I have 2 left over and they're on the top. So wherever you have the most is where you're going to have your leftovers. So 12 is more than 10. So you're going to have your leftovers on the top where the 12 was. Okay, so we have x to the 27th, and we have x to the 6th. And then we subtract, and we get x to the 21st. There's another way we could have done this problem. Sometimes on the inside of parentheses, you can reduce ahead of time. Like back up here, I could have reduced that. I could have said that was x to the 1st power. And then raised to the 2nd power. 1 times 2 is 2, and get x squared. So here, I could also say x to the 7th, because I'm going to subtract. When it's division, you subtract, and then raise that to the 3rd power. Then when you have a power to a power, you multiply. So I get to the 21st power. So I get the same answer no matter how I do it. Now, here I can't mix x's and y's, so be on the lookout for that. I think there's one on your homework like that on the back. So here I have x to the 6th and y to the 6th. I multiply here, multiply there. And I can't do anything with that because an x's and y's don't mix. Now let's look quickly at some negative exponents. Again, if you have x squared, 4, 5, 6, 7, 8, 9, and you cancel out, you're going to have x to the 7th on the bottom in the denominator because 9 is bigger than 2. And so your answer, your leftovers after you cancel out are going to appear on the bottom. So when you say your subtraction problem in your head, don't do 2 minus 9 because you'll get a negative number. Do 9 minus 2 and then put your answer where you started saying your problem. You said 9 minus 2, so you said 9 first. So put your answer there. We're going to say 13 minus 5 because 13 is bigger than 5. I said 13 first, so my answer is going to go here. And I put a 1 on the top. Okay, work your x's separate from your y's. Don't even look at your y's right now. So I'm going to have 10 minus 8. I said 10 first, so it goes on the bottom. Y to the third, 7 minus 3. I have to have something on the top, so make sure you put a 1. Over here, oh, now the top is bigger again, kind of like normal. 33 minus 27 is 6. So I just have an x to the 6th. You don't really have to have a bottom in that case. Okay? Work your x's and y's separate. Don't even look at the y's right now. Just concentrate on the x's. I have x to the first and x to the third. If I cancel out, I have x squared left over on the bottom. 3 minus 1 is 2. And then I have y to the 6th and y to the 1st. When you don't have an exponent there, it's a 1. It's not a 0. So there's some like that on your homework. Some of them say 1s, some of them don't say anything. So 6 minus 1 is 5. You have y to the 5th. Over here, we're just doing the same thing again. So 4 minus 1 is 3. Where do we put it? Well, we started saying our subtraction problem with the 4, so we put it on the bottom where the 4 is. 10 minus 4 is 6. So I'm going to put it down there where the 6 is. Then I think that must have been it. Okay,